um, there are 9 counters in a bag. There is a number on each counter, as you have shown here. So these are the number of ones, twos, and threes. All right. So Carl takes so here the probability of 1, just from what we have here. Um, so probability of 1 will be equal to 2 over 9, and here probability of picking a 2 will be equal to 3 over 9, and probability of picking a 3 will be equal to 4 over 9. Okay, so let's carry on. So Carl takes at random 3 counters from the bag. He adds together the numbers on the 3 counters to get his total. So again, this is without replacement. This is without replacement. Okay, so he adds together the 3 numbers, the numbers on the 3 counters to get his total. Work out the probability that his total is 6. Again, I'm going to use a tree diagram to represent this. This is optional. You don't have to use a tree diagram. But again, I'm just using it so that you can be able to understand what's going on, to visualize this solution. So, well, the first counter that he picks could be 1, can be 2, can be 3, because those are the only number of counters that have 1 or 2 or 3. This is the first selection. Second, again, we can have 1, 2 or 3, 1, 2, 3, 1, 2 or 3. Third, we can have either 1, 2 or 3, 1, 2 or 3, 1, 2 or 3, 1, 2 or 3. Yep. And this is just to help you visualize on what's going on. Like I said, you don't have to use a tree diagram at all, but if you think it helps you, then well and good. Okay, so we want a total of 6. So from this tree diagram, I'm going to check which branches give us a total of 6. So this one is not giving us a total of 6. This one is not. This one is not. This one is not giving us a total of 6. This one is not. This one is giving us a total of 6. And again, carrying on, this one is not giving us a total of 6. This one is giving us a total of 6. This one is not, not, not. This one is giving us a total of 6, not a total of 6. This one is not total of 6, no, no. Again, here, this is not giving us a total of 6. That's a total of 6. That's not. That's a total of 6. That's not. That's not. And this one's here. All of these are not giving us a total of 6. So let's find out how many are they. 1, 2, 3, 4, 5, 6, 7. So 7. So this can happen 7 ways. Out of these 7 ways, let's check what each of these way is. So this is 1 followed by a 2, followed by a 3. This is 1 followed by a 3, followed by a 2. This is 2 followed by 1, followed by a 3. This is 2 followed by 2, followed by 2. And this is 2, 3, 1. And this is 3, 1, and 2. And this is 3, 2, and 1. So there's a pattern here, if you notice. So for 2 followed by 2 followed by 2, there's only one way of getting this. So this is one way of getting that. This is just one way. But for these others, we have 1, 2, 3, 1, 3, 2. I mean, the numbers are just the same, but switched around. They're different combinations. So basically, seems like there are 6 ways of getting this. So here we have 6 ways of doing this. So I now want to apply the probabilities of each of these numbers to work out this problem. So I'll start with probability of 2 followed by 2 followed by 2. So probability of 2 followed by 2 followed by 2. So let me just erase this. All right, so probability of 2 followed by 2 followed by 2. Now, originally, if you check the totals, originally the number of 2 are 3. So the probability of the first selection is 3 out of the total, which is 9. But then after you pick one counter, the total number of counters, which are 2's, reduce. So you'll end up with 2 counters, and the total reduces by 1, so 8. And then again, after the second selection, the number of 2's will just be 1. So just 1, 2, and then total will be 7. Now, if you multiply this out, the answer will be equal to, numerator will just be 6, and the denominator will be 504. Okay, now for the others, there are 6 ways of getting 1 or 2 or 3. So say there are 6 ways. There are 6 ways of uh, getting 1, 2, or 3. So basically, what you're going to do here is we don't have to work out the probabilities of each branch. What we can do is just pick one branch, work with it, and multiply by 6. Yeah. So so what you're going to do here is just pick one of them. Actually, I can pick the first one, 1 followed by 2 followed by 3. So that will be equal to, because there's 6 ways, so 6 multiplied by, so probability of the first counter being 1, if this is the first event, that will be equal to 2 over 9. And then the probability of the second event being a different number, let's say being 2, will be 3, because I haven't picked any 2's, 3, but the total number of counters will be 8 because the first one was 1. So that will be 8. And then the probability of 3, that will be 4 over the total number because the first one was 1 and 2. So the number has reduced by 2. So that will be 7. Now, if you multiply this out, that is same as 6 multiplied by 24 over 504, which gives you 144 over 504. All right, so now we need to add these two answers together. So getting a sum of 6 will be either be this or that. Okay, so that will be either 6 over 504, or, and remember, or means you add 144 over 504, and this will be equal to that's 150 over 504, which will be equal to 25 over 84. And that's how you work out that question. So the tree diagram definitely helps to visualize what's going on.